our project, which is Reddit AITA, which is essentially MIB this work, which is essentially a progression in natural language processing in which we try to understand social norms. If you're not aware, this is a subreddit on the platform Reddit, wherein people discuss stories and based on discussions with multiple Redditors, they decide whether they were in the wrong here or they weren't in the wrong. So the real life implication for this is that we can essentially use the model we've developed in this project to come up with an automated content moderation system for flagging toxic behavior in, let's say, chats or public platforms, or even just for social science research purposes, like we said before, for tracking norm shifts that may occur. Yeah. So after that, let's talk a little bit about the ML approach that we have here. So this is a text classification problem, wherein the input is the raw text of the user story, which is the title and the body, as well as the output, which is whether they were in the wrong or not. For the data collection, we went directly onto Reddit, and we purposely didn't pick Kaggle because we knew that that would be too easy and it wouldn't really be creative in terms of how, or indicative of how a real life, data would perform. However, this had many problems. We had to be very creative with the data scraping, as we had to get bypass the very strict scraping laws that Reddit has after they removed the ability to create apps. As such, we made some browsers, some agents, and then scripted from there, which was able to give us all the data we needed. Some problems that came up with the code was that while we were doing this, there were controversial posts initially that we included. The problem with the controversial posts were that they didn't even have a classification on them by the moderators, so a machine wouldn't know what the label was. It was just classified as unknown. And the second thing that happened, which was the biggest problem, was that we had a lot of label noise, which happened because a lot of posts were either removed or taken down, which or deleted, so which we account for here, just to clean up and get the proper thing that we have here. Now we can start to discuss a bit about like the baseline models we use. So the first one is a naive Bayes model, and the second one is a TF-IDF model. So in both of these, they simply look for keywords and try to see um, essentially where or what is the problem. As we can see here, naive Bayes received an accuracy of 0.5694, while logistic regression received an accuracy of 0.611, which was decent enough as is, but we wanted to do better. So as such, we went with the fine-tuned model distilled build, which is a transformer model, and unlike the baselines, it reads the entire sentence to get context. So even the change and a pivot at any point in the sentence that may lead someone to be in the wrong to be in the right is clearly understood by Distilbert, which we will also show in a demonstration of what's going on here. So if we go down here, we can actually see the results of our training. We see that we reach almost 70%, and it shows 68% right now, but if we retrain, I'm sure the accuracy would go up, and we would have, better scores, as we can see here. Now for a bit of a demonstration of like our project, we have some sampled sentences here. And what I'm going to do is for the first this thing, I'm going to take our Reddit AITA, and I'm going to first make Distilbert see whether or not it was able to predict um, whether the classification is right. So just for that, let's just copy paste these sentences we had from before. So as we can see, the first sentence, clearly, in the wrong, the person who made the post. Second sentence, not in the wrong, as it was someone else. And the third sentence is the trick sentence because over here, while it seems like it's wrong to begin with, the pivotal context that comes is from the last part of the sentence, which this Dilbert accounts for and, accurately verifies that. However, if it's a different story with, oh, sorry, it is a different story with uh, the baseline models, wherein if we try and run this real quick, and we do the same thing wherein we put in the sample sentences, one, uh, two, and three. So now what we can see here is that obviously they're getting the simple, whether they're in the wrong or not, pretty easily. But the problem comes from when we had that problem sentence before, which is that it sounds wrong until the end, until it has context, which both of these just do based on keywords. So naive Bayes was right in this case, and logistic regression wasn't. There are a ton of other cases in which they just would not be able to discern whether or not this is true, which is also correlated to why the accuracy is so low. Because there's no context being taken in for the whole sentence, while in Distilbert there is, which is why we decided to go with that model as our final one to begin with. Yeah, so that's our project. In conclusion, we learned that for subjective tasks like moral judgment, data curation is just as important as the model that we choose to make here. Moving from a noisy, controversial data which had like um, a lot of holes, we came up with the consensus data, and we would honestly note that to be the biggest part of our success, which is how we collected data and what kind of data we had. So yeah, we've clearly demonstrated the right way to data clean, use the transform architecture, and how it was better than the baselines. And yeah, that is our project. Thank you for watching.